Mark, and today we're going to be talking about Java does what now. When I submitted this, I submitted it as Java 21, and then as I was updating it, I realized I wanted some Java 25 things in there, so there are a few slides that aren't about Java 21. And I will highlight which ones those are because those aren't things that you can use in production just yet. But Java 25 comes out this month, and it's a long-term support release for those of you that's important to, so great to know. At the end of this presentation, there will be another raffle. I'll be giving away this book. I've written a number of certification books, Java 8, 11, 17, and 21. We will be updating for 25. And with a different co-author, I wrote this book, Real World Java, which is meant for people who know the language and either aren't ready for an industry book because it assumes you know a lot about the ecosystem, or they're rusty, or their project's been on Java 8 for a while, or just they've been pigeonholed into something in particular and haven't gotten a chance to see everything that's out there. So great book. Obviously, I recommend because I am nice and biased. All right, let's get started. This is my Java 25 flag. Not a feature flag, but it is a flag, in order to tell that you can't use this in production yet. I don't like using preview features in production. So while these are in Java 24 as preview features, they are in Java 25 for real and much safer to use there. Raise your hand if you've heard of scope values. Cool, you're all going to learn something new. Scope values allow you to create a value. It's called a scope value, as you might expect. Okay, I lied. I move around more than I said I did. Yay. So scope value new instance gives me a scope value, and I'm using a generic. So in this case, it's a list of strings. And the idea of a scope value is you have this value that is supposed to be immutable, and you can use it within a scope. So in this case, I've got scope value where I've got my scope, which is the thing I'm passing in, and then I've got a lambda inside, which could be a direct lambda or a method reference or a call to pretty much anything that is allowed to use my scope value. And the idea of scope values is they're safer to use than thread local because you're able to control the scope. If I have a thread local, it's available anywhere in my program, and anyone in my program can change it, and anyone in my program can use it, and that's not usually my intent. So especially with a lot of the new concurrency stuff, being able to control who's using it is a big improvement. And you notice I said before, scope values are supposed to be immutable. If you've been around the block, you've probably heard the interview question of, I pass in a blank and it's immutable, how would you fix this? And the spoiler of that question is it's not immutable, because if you pass in something that's not immutable, guess what? It's still not immutable. So if I'm passing in a list and my list is a nice array list, I can add and remove anything I want from that list, and now I no longer have an immutable value. So you have to pass in an immutable list if you want your list to be immutable. Scope value doesn't magically make it immutable, nor do records or anything else of that sort. So scope values are new. The immutability problem is not. And if you get an interview question and your interviewer is on top of things, they will update their immutability question to something like this so that they can try to throw you with the scope value thing. But the principle hasn't changed. You have to protect everything you pass in. And that's true for a plain old Java object too. If I pass into you a list of strings, now you have a list of strings, right? What is the first thing you do? You either make a copy of it or you add an immutable wrapper to it so that you've got something that's safe and available for people to use. To the guy with the phone, this entire presentation is on speakerdeck.com/Boyarsky, so you don't have to take pictures. You can just download it later. Yes. It helps to be in the moment and not have to take pictures of each slide to remember stuff. So the output of this is 0 because I've called list remove, and my nice array list with the T. Oh, I spelled tea party wrong. I added that for you guys. It was supposed to be the tea party. I added that for Boston. Yeah, the code part I was super careful about. Anyway, it's an empty list because I removed something from the empty list. So now we do actually have the tea party shipped. You can see that I intended to do that. And here you can see that I'm calling scope.get on my new instance, but I'm passing in a string. And this time I get, oh, for crying out loud. As a related note, this is the first time I've given this slide deck in my entire life, as you can see. I proofread the scope value parts of it super carefully because that was the part that was new to me. And the word T, I've now spelled 3 different times.
Well, one of them is right. So.
It's that one.
The clock is right twice a day, right?
Yeah, and the best part is this mistake is on the internet forever. There's less errors as we go on, I swear. All right. So the behavior of this is scope value only provides a getter because it's intending for it to be immutable. And if you provide a setter, you don't do that. But you have to make sure that the thing you pass in is immutable, or plop, it doesn't work. And it's worse when you add something that you think is immutable and isn't, because you're making an implicit promise, right? You're saying you're using a scope value, you're sort of advertising that you expect things to be immutable. And the reader of your code now expects things to be immutable. If you've lied to the reader of your code, you've now given them something extra to think about. And now they can't trust anything else in your code because who knows what else it does. And it's the same deal for records. Records are immutable unless you pass in something that's not immutable, in which case your field is not immutable. So we can see here we've got a fake immutable record because it's passing in the same list, and I've got the same problem. I don't protect it, and therefore it's not safe. Our next topic is importing modules, also new in Java 25. Also, as you might imagine, a slide I've never given before. Let's see if my typing skills have improved. So in order to use a module import, use import module, and you give the name of a module. It's okay if you're not using modules. This applies to JDK modules as well. You can be the consumer of a module in a nice non-modular project. It still applies. I've imported Java SQL, and now I can use everything in it, all the packages that come with it, result set, prepared statement, Java SQL date, and all of that good stuff. And if I run this, it does exactly what I expect. It tells me that date is Java SQL date, which is probably not a surprise to anybody. But that's not why we're here. We're here for things that don't always work so well. So now I'm importing two things. I'm importing the module Java SQL, and I'm importing Java util star. And you may have seen this before if you've been around the block a few times. It was the example where you imported Java util dot and Java SQL dot, and then you tried to use date, and Java said, what's that now? Right? You've got to tell me which one you want. So you would think that the same thing would happen here, right? Because that would be logical and consistent, and not what it happens. You get Java util date here because there's now an order of precedence with imports. And a lot of this is backward compatibility going on because we value backward compatibility in Java above everything else. Everything. So it's saying here, well, you specified a regular import. That's probably what you want because you also imported the whole module and you wanted a lot of stuff with that. So that probably wasn't what you wanted. Not really what I had in mind because I import Java util star for lots of things like, list, right? That doesn't mean that I wanted a date. So you have to be careful here in order to get the desired behavior. And then here it does work as you would expect. If I say I want Java SQL date, I get Java SQL date again because I've explicitly specified what I want. This totally looks like it's going to be a nice certification type question on the Java 25 exam. It's right up that alley. It's super confusing and it's great, and we have a question.
So if I understand the order of precedence and interpret when Java's trying to figure out which date you're using,
yes,
it follows the same sequence that you have them listed. But does that actually matter?
No. What matters is what I have there. It's that Java SQL date is more specific.
It's just based on the specificity of the import.
Yeah.
Not the order the import statements are made.
Okay. Yeah, I could put these in any order.
Okay, that's what I thought.
I'm making a note about my Tea Party ship thing because I'm giving the same presentation later in the month in New York, and it would be super embarrassing if it was still wrong.
So why wouldn't you just be clear and just say java.sql.date equals new date?
You can, but that wouldn't highlight the behavior I'm trying to show.
Right.
Yeah, that's sort of the theme of this presentation, to highlight surprises. So if you see them in the wild, you're not surprised. If I was writing this code for real, I actually wouldn't write Java SQL.date. I would set my IDE to not use wildcards and not have this problem in the first place.
You wouldn't use Java SQL date either.
Yeah, unless I was working on some super old code. I suppose I'd have to go back in time to have that problem. Henry?
So if some of us are crazy enough to just import both dates,
that will also fail because we're back to the problem of you haven't given the compiler enough specificity. And if it's ambiguous, the Java compiler solves that by I don't know, you tell me what to do.
So before you add the import java.sql.date, yes, in that scenario, would you get any compiler warnings?
I don't know if you get a warning because this is a Java 25 feature, which is not out yet. So I don't know how the compiler is handling it. In preview mode, you do not get a warning though. All right, given all the questions, I see people learn stuff. Good, off to a good start here. So what we saw here is explicit imports win over wildcards and both win over module imports. And if you're ever doing this or planning to take the Java 25 certification when it becomes available, useful information to know. If not, it's kind of a nice parlor trick to be able to tell people that you know this, because it's like, well, if you know this, you know everything there is to know about Java. The next section is the home of future gotchas, which are things in Java 25 that I think are in this space, but not necessarily warranting their own section. And then we'll get into things that aren't in 25. So the first thing to know is that this is legal code in Java 25. I'm super excited about this because, as mentioned, I mentor a high school robotics team, which means every year I work with 9th graders who are learning Java for the first time, which means you have you're going to type public static void main string brace args paren, and we're not going to talk about what any of that means. Ask me again in a month, right? Not having that conversation is nice. And this is pretty intuitive, and more importantly, I can talk about what everything means here. Void means it doesn't return anything. Main is the name of the entry point. IO is a class that has some helper methods, and print does what you think. It prints stuff. Like, isn't that a great intro to the language? It's like, this is awesome. And it's nice for us too, because system out print line, which I know nobody types because you have your ID do it for you. IO is shorter, right? I can't autocomplete that because it's only 2 characters to begin with. Pretty good. So this does exactly what you would expect. It outputs intro, no problem. The gotcha here is that if someone doesn't know this is legal, they're not going to know this is Java, let alone that it works. So good to know, don't be caught by surprise. It's also nice for prototyping. I don't really like using JShell because I like having everything in one place and running it multiple times. So not having to type so much when I write a throwaway class is pretty nice as well. Yes?
I'm an old Java person and what the name of the class would generate?
There is no name of the class.
The compiler generates it.
Yeah. So this is actually 2 new features. It is compact classes and compact name methods or something like that. I forget the name of it, but those 2 features combined allow you to write this code. Because does the name of the class really buy you anything if you only have one class? Right? You don't care what the class is called. The author doesn't care what the class is called. It's like, this is nice. Right, exactly. And you can also use a feature from a couple versions of Java from a while ago to type Java, name of file.java, and not even have to compile it. So it compiles it in memory, it runs it in memory, you just get your run.
If you don't have a class name, how do you run it?
You still have a file name.
You have a file name.
Yeah. So your file should be named like Fred.java or whatever you want it to be named.
So it's taking the file name and making that the class name.
Implicitly, yeah.
Yeah.
But the key is you don't have to type it and you don't have to explain it to people. But again, it doesn't matter what the class name is, right? It's just like run my method and print out intro. I don't need all of this ceremony. And then when people are new to Java, you don't have to introduce classes up front and you don't have to introduce statics up front. You can just get going. And then when they're ready for it, you can explain it. Next up, we have flexible constructors. This one's a little more useful to the experienced folks. So if you were thinking the previous one was a parlor trick, this one you might use in your actual day-to-day life. With constructors, we all know that the first line of a constructor has... Yes, we all know the first line of a constructor has to be super or this or implicit super. But sometimes you don't want it to be, and you wind up with this line like super, call this method to get argument 1, comma, call this method to get argument 2, and that goes on forever because you have to shove everything into that line. Flexible constructors are the solution to that. You can call very specific things at the beginning of your constructor and then get around to calling super or this later. And they are very specific things, right? So like you can't just be like, oh yeah, it's the Wild West, I want to change everything. I don't know all the rules by heart yet. I need to learn them. So, be careful. But it introduces the concept of a prologue and an epilogue where there's explicit parts to the constructor before and after your call to super or this, and you can do stuff there. And that's nice because, as we said, you can put shit in front of the constructor, and we want to do that, right? That's why this is exciting. It's not like, well, who cares, right? And count equals 0 is not the most useful thing you could do there, but it's short and it fits on a slide. So, we went with that. But really nice to be able to have that control and have it do what you want. And even the debugging is useful for someone who's new to Java. It's like, I want to know that this happened. It's also useful if you're trying to understand the flow of something because it's not implicit anymore. You can actually write what's going on.
I know you said you don't know all the rules and you had a little kind of standing curtsy about it, which is nice.
I need to
But-
learn them.
Yeah, that was cute. But like, do you have any? Can you give me like what kinds of things are
You
not
can do-
allowed? Like what can't you do?
Yeah, so
Okay.
you can't do stuff that corrupts the state of the object. And that's the problem, that I haven't learned what corrupts the state of the object yet.
Corrupts.
There are some things you can do where you're essentially introducing a cycle. Oh, I remember one of them. You can't set a variable in the superclass before you call it because the superclass doesn't exist yet. So if count was in Flexible's superclass, that would be a problem.
Okay. So Flexible doesn't have a superclass.
We're imagining now. Yeah.
Well, everything does have a super.
Okay, but suppose
But
Flexible
it's-
extended foo and count was in foo, then this would be a problem because you'd be calling something that doesn't exist. Right, and there's a few other cases like that that are in the space of cycles that you create problems for Java and it doesn't know what to do, and the solution is to ban them. The reason I made a joke of it is I need to learn those super well because that's something that is absolutely going to be on the certification exam. So I need to learn it and I need to be able to explain it to people. I've been waiting though because I was waiting for the JEP to be final, and then it was final and I didn't have time to memorize it. But that's on my list of things to do in the next month because it is going to be important for me to know. It's not going to be important for people who aren't taking the certification to know because when I read it, it was all in the space of why would you ever do that? It's not stuff you're going to encounter just like naturally. And even if you did, the compiler would tell you you couldn't. We're now done with Java 25 features. So everything else in this presentation, with the exception of one minor thing that I hid in another slide and will point out later, is available in Java 21 or earlier. I didn't label where everything was from because Java 21 is now a couple years old. I know we're not all on it yet, but it's reasonable to assume people have at least heard of Java 21 by now. But before we get to that, let's do a quick little survey of what people are on. Who is on Java 21 or later? 17 or later? How did any hands go down? That's not how this works. 8 or later? I'm scared that I don't see everybody's hand. Is anyone still on 7? 6? No, I don't believe you. All right, so we've got our traditional switch statement here. I hope we all know what's wrong with this, but someone call it out.
No breaks.
Yeah, no breaks. That one's old news. You have to have a break, otherwise it outputs everything. All right, so we know we have to have breaks, and that's not surprising to anybody. What might be surprising is what this does. Does anyone know what this one does?
Won't throw no pointer exception.
It will not throw a no pointer exception, no. Any other guesses?
Spoon hands good.
You would think, but no. It's a compiler error. You are not allowed to use null in a case, mostly. In the days of like Java 7, Java 8, Java 11, it was a true statement that you couldn't use case in a null, to the point where no one ever did it or cared about it. It's not 100% true anymore, as you're about to see, which is why I'm highlighting the fact that it was illegal. And it is still illegal in this code. Where it's not illegal is in the new style switch statements. So in a switch expression, you can do case null, or a switch statement with pattern matching, but those are ugly and people don't do those. So here you're allowed to do it because we're matching by type. It's not obvious we're matching by type here because you don't see any types, but we are in fact matching by type, and therefore null is allowed because if you had a null, it wouldn't be a type, and therefore it wouldn't match the types that aren't on the screen. So it's kind of cool because if you look at these, they do the same thing, except that I don't have a break on the first one. But it's doing the same thing. It's comparing clam chowder and pizza, and it's outputting something. But because I'm storing the result there in tool, that makes it a switch expression, and that adds the fact that I can use null, and it also adds the fact that these cases need to be exhaustive. That's super important. You can't declare a variable to just some random undefined value. We don't do that in Java. So if you don't have a default or something that ensures all the cases are executed, the compiler is like, wait a minute, I can't do that. Right? Just like if I wrote case tool, semicolon, system out print line tool, the compiler would have a problem with that. If my case statement doesn't handle all the cases, the compiler will have a problem with that. All right, so now it's valid. I have to get a spoon because I'm having soup. Perfectly reasonable thing. So to review that, a traditional switch statement needs a break. Not a surprise to anybody. We're not new to Java. You can't use null when matching the string because it's not a non-null compile time expression. You can tell that came from the spec because it's right off the tongue. But nulls are allowed in pattern matching. Great. So now let's look at this exhaustive thing that I just gave a little preview of. This example does not compile because it's not exhaustive. So suppose I had food set to cookies. Cookies, those were good. Nothing would happen, tool would be undefined, so the compiler doesn't let you get away with that. You have to say what's going on in order for it to work. I have to cover all the possible inputs. I have to be exhaustive. Great. Now I've added case object O. Now the compiler is happy because I'm using pattern matching. Remember before I said that I was using pattern matching even though it didn't look like it? Oh, better, it looks like it. Yay! Case object O is pattern matching. It's saying if it's an object of type O, which is all objects, it matches unknown type. And I can do this with more specific things as well. I can do case string. I can do case string when string is empty, case string when not empty, all of that. It's not that smart, right? If you start using obscure conditionals that go together, it doesn't always know they're the same. But for the basic things, it does. Now we have an interesting one. I have a case object and I have a default. The compiler is smart enough to know that you can't do this. Default is unreachable because case object is going to match everything there is to match, so it's impossible to get to default, right? And you've seen this with other things like catches. You can't put them in the wrong order because you can't get there. And it's the same problem here. You can't get to default. This is my surprise little Java 25 thing. You can use underscores instead of variable names. But everything else on this was available in Java 25, so I just threw that one in for fun.
It didn't have the case null at the top.
Mm-hmm.
Would the default be appropriate in that case?
No.
You get a null pointer.
No, you would not get a null pointer because case object null is an object. Think of this as an instance of. So if I do null instance of object, it returns true. Good question, though. That's pretty obscure. Okay, so what happened here? Default and object both handle the fall through. You can't have both because that wouldn't tell Java what was going on. So continuing on this journey about all possible inputs and exhaustions, we have an enum. We've got the 4 seasons here. You don't have to study them. They're the real seasons. There's no trickery in there. And now we've got a variable cold, which is a season, and we have a switch statement that handles the 4 seasons. And you might notice that I use a mix of just the enum value and season.the enum value. That is legal now. Didn't used to be. And you can also see with spring and fall, I put them on the same line to show that you could do that with case. That is also legal now. Great. Compact code. And this is fine because the compiler knows that I've handled all 4 enum values and there aren't any more. I don't need a default in case one is added in the future. If one is added in the future, if you invent a season like the rainy season, this code will stop compiling, but it does compile for now. Or if you're in California, you could add the fire season because that is totally a season.
Or mud.
Yeah, they have a lot of seasons. So enums and statics are now allowed inside methods. That didn't used to be true. That was added as a side effect of some new features. The enum name is optional, and it's exhaustive because it's an enum. Awesome. Next up, we have our enum again. This time, I did not handle all the cases. However, it's okay because I'm not assigning the results of the switch expression to anything. And because I'm not assigning it, it doesn't need to be exhaustive, right? It's not the switch expression that's making it exhaustive. It's the fact that I'm doing something with the output and therefore it must have output. No problem, no output, no message to do anything with it. So switch expressions and assignments don't have to be together. And I mentioned the underscore already that I just threw in there for fun.
Underscore still there, it's gone. Use it.
You can use underscore in Java 22 and up.
Oh.
I included it somewhat randomly because I wanted to show it off, but it's not that important. You can use one letter variable that isn't underscore in earlier versions and everything behaves the same. All right, so null. Null is so fun in switch expressions. All right, we've got a switch expression here, clown, case null, default. This works fine. I was shocked that this worked fine when I saw it the first time because it's like, but we've checked the string before we've checked the null. And it works because we're not referencing the variable. So it can say that null is not clownfish and be fine. Whereas if I said case string when s dot empty, it would be a problem because I'd be calling a variable with s. So in hindsight, this makes sense, but it was super surprising the first time I saw it. And then it gets better. So now we have the same code without the default. So it's like, all right, fine. This seems like it should work because it's the same thing as before, but no. Now it doesn't cover all the possible inputs, so I've got a problem, and the null has distracted me from it, and all is not well and good because I'm using the variable value by printing it out. So that's fun. Now we have our traditional switch statement. This time it has the breaks, and this one does work. So notice I have a case and a null in the middle, and it has a default. So far, this is all consistent, right? A little odd that I'm sitting here harping on nulls and defaults, but it's consistent. So then we have our last example where we have a traditional switch statement with the case and the null and no default, just like the previous one. We're not assigning it anywhere. So this should be fine, except for the fact that it isn't. And Scott and I can't figure out why. So we documented this fact, but it does work. The best thing we can tell, and we're not sure if this is the reason, but we think it's that using null makes it pattern matching and changes the behavior. We think. Because in old style Java, you couldn't have the null. So it was clearly not pattern matching. So we think the addition of the null is making it pattern matching and therefore changing the rules and making it be exhaustive. But we're not 100% sure because it's a little screwy. You will never encounter this in real life, of course, but this is a Java does what now talk, so it's like, really, it does that. Huh. Okay, I think we're done with that, and we're in the realm of things that actually make sense. Nope, one more. So the order also matters. You can't have default in the middle of the case. It has to be the last. That makes sense, right? Because the default dominates, and nothing after that will ever get hit, and everything is fine. Great. We've got our traditional switch. We have default at the beginning. That's fine because the traditional switch just is like, yeah, I'm going to run through it. Everything is okay here. And it's the same deal. In pattern matching, the order matters. In the old style, it doesn't because it didn't used to originally. I hope your question is one I know.
Back to the first pattern, yeah.
That one?
No, sorry, that one.
Okay. This one I like. Good.
So in this, I don't know how you call this switch, but
A switch expression.
Why does the order matter?
The order matters because a switch expression works a lot like a catch where it's going through them in order and finding the first one that's matching. So in this case, I have a number fish and it says this is fish anything. Yeah, it is. So then it never gets to case integer because it ran the default. Whereas in the traditional switch, it's fine because the traditional switch relies on the break. So it still matches the default because it doesn't match 2, but it breaks and it doesn't get to case 2. And if it was case 2, it would match case 2 because this old switches didn't worry so much about the order. So this makes sense. It's just, there's so many things in this space. It's fun. Okay. I'm done talking about switches. So if you felt like your head was exploding and you tuned out, it's okay. It's a reset. We're on to a new topic. You don't have to worry. Our next topic is one that is not a new puzzler. It's classic, which is removing stuff in a loop. So some of you may have seen this before. Some of you may be new to. So I've got a list, Red Alliance, Blue Alliance. For those of you who have heard of FIRST, shout out to them. And we go through our list and we try removing things from the list and we get a concurrent modification exception. This is a well-known behavior. You can't do this. because I'm trying to iterate through my list while changing the list. So the first time it goes through, it's like, oh, I want to remove stuff. And the next time it's like, wait a minute, the element's not there anymore. What'd you do to it? Okay, great. So now we have another example, which we just have red alliance, and we try to do the same thing. But what's fun about it is that this one works. And the reason that it works is because we're only having a small number of things in the list. So the first time through the loop, it says red. Okay. And then it says I want to remove it. Sure. So now my list is alliance. The next time through the loop, the for loop remembers that we're up to the second element. It's like, all right, are there any more elements? No, there's only one element. Oh, okay. So since there are no more elements to confuse it afterwards, you don't get an exception. Whereas when we had the third element, it said, okay, we're up to the second element. No problem. There's a second element. Let me go through the loop again. Where'd it go? And you get different behavior. And the reason that this one's interesting is because you have to have sufficient test data in order to uncover this, or you have the problem in production where it's way less convenient than in your JUnit test. So we talked about it goes through the first time it's red, it removes red. Now it's alliance. The for loop checks the size. It saw the element. All done. And before it goes through, the size is 3. It's not done, and then it blows up. The fix to this is to use a proper data structure like copy on write array list where you can iterate through it and have it do things. So here we're removing each element and the output is that there aren't any elements. But of course, this whole exercise is silly because you could have just cleared the loop. You could also, if you want to write a bunch of unnecessary code, you can use a lambda and say you want to remove everything from the list. And you never have to do this exercise where you loop through the list and remove all the elements in the first place. Clear is great. Creating a set. This one was from Java 11, I think. I've got a string array, all the words in the world, and I want to turn it into a set. And I want to do it without a loop or a lambda or a stream or anything of that sort because I'm lazy and this seems like the type of thing that should be able to be done in one line. Okay, so I use arrays as list to convert my array into a list. And then I put it in a hash set and I print out the set and it does exactly what I want it to. Yay! It's so nice when that happens. Okay, but I was like, well, I can change this. I can improve this because now we have a set.of, so I can create a set on one line and I don't have to go through all of this drama. So I do the same thing as before. Set.of takes var args, so I can pass an array to it. No problem. I try to print out the set and it complains. And the reason it complains is the set.of method has in the Java doc that all of the elements you pass in must be unique. Hash set does not and deduplicates for you. I found this out when I upgraded to Java 11 and ran my unit tests and they suddenly stopped working after I just did some refactorings on the phone that shouldn't change anything. I'm really, really, really glad I had that unit test. So what's going on here is that the documentation says you can't have duplicates and we should read documentation instead of assuming we know how things work. We all do that, right? No, just me.
Or you could just assume that they did the smart thing instead of the dumbass thing about making that you can't have duplicates in the var.
Someone thought it was a good idea.
You're an idiot.
Wasn't me, but someone thought it was a good idea. Next up, we have another you should read the docs.
Yay for unit test.
Yeah.
Yes.
My next one was also caught by unit test when we upgraded. Yes. So this was also caught by unit test. I have a list here. That's fine. It has 2 elements in it. I know there's no coffee in the harbor, but I hope you're okay with that. So then I put it in a list stream, sort them, and put it back in a list. And now I have a ordered list, coffee, tea. I add milk to the beginning of it. I now have milk, coffee, and tea. Great. This works fine. Everything is good. But my compiler, helpfully in the IDE, warns me that I don't need to write collectors to list anymore. I can write to list. Great. That would make the code shorter. I like getting rid of IDE warnings. It makes the code cleaner. It makes it easier to see the real problems. I'm going to click accept and make that change. And then my code blows up. Like, the IDE told me to do this. Like, this wasn't me being clever. The IDE told me to do this. Exactly. Collector to list returns a mutable list, and to list returns an immutable list. And therefore, when I tried to add milk to it, I've got a problem because my list is now immutable. Now, I will grant you that it is poor form to return something from a stream and then start messing with the results. But, you know, I did in many, many, many places. They were all in unit tests because I don't worry so much about good form in unit tests, but I was absolutely doing this. I did refactor the code to not add stuff to the list and make a copy of it because I did want my compiler warning to be gone, but I was unpleasantly surprised by this. And the Java doc does say as well that this is a thing. So be careful. Even if your IDE tells you to do something, it's not always safe to do, alas. Next up, we have back collections. This one's not new either, and it's pretty short. So we've got our little rivalry there with the baseball teams, and we have our set, and we try to remove something from the set, and it removes it, and everything is good because it is a back collection. I do the same thing here. I remove it from the keys, and again, it removes it from the original map because it's a back collection. Keys, set, values, and entry set are all backed. You change the one it gives you, it changes the original map. No problem. That one we're used to. It was probably screwy when we heard about it the first time, but that time was a long time ago, and that's wonderful. We're over it now. So now that you've reset and are like, okay, that one I knew, great, no more traps, it's time for var. var is nice. It gives you less code to write if you use it carefully, and you can, right? In this example, nums is clearly a set. I don't need to say the fact that it's set twice on the same line. It gives me that information. So I have my set, and I'm adding the results of MathMin to my set, and then I'm adding the number 3 to my set, and at the end of the day, I have a set that has one number in it. The number is 3. Wonderful. I was expecting that to happen. It happened. Great. No more surprises. I don't want more surprises. But that's not how this presentation works. So I have the same set, and I add math.min to it. We know that's 3. We saw the previous slide. And then I add math.round 3.14 to it, which is also 3. And then I output the result, and there's 2 3s. The reason there are 2 3s is these guys are different types. Min returns an int. Round returns a long. And I never specified what type this was, which means that it is a hash set of type object and is happy to store integer and long as if they are separate objects because they are. And therefore, you can get a set to return the same value twice because 3 displays as 3 regardless of whether it is an integer or a long. That one's a little bit of a parlor trick, but it's kind of cool. And it does show the importance of specifying what your type is when you type it, and don't assume that it will be taken care of for you.
But they're both ducks. Come on.
Okay. Next up, we've got ourselves 2 lists. One is an empty list of integers. I said it was an integer. I don't have to worry about what type that is. And the other is 1, 2, 3 of integers. I pass them into a stream. I get a flat map to get all the elements of them. I add 1 to them, and I print them out, and I get 2, 3, 4 exactly like I was expecting to. Awesome. So now I'm doing the same thing, except I'm no longer specifying the type. So we know that this may not go so well, but it might see. I think this one's going to be okay. So I still have my empty list of integers and my list of also integers 1, 2, 3, and yay, I get the same result. All right, I'm on a roll. var is the best thing in the world, so we're going to change the first one to be var, and then everything's going to fall apart. Because var list of does not specify the type. There's no information there to tell it that it's a list of integers, so it's not. It's a list of objects. And I'm trying to add my now object to 1, which is not a thing. So even though there's nothing in that list, the compiler doesn't know that, but it knows I'm trying to do math on it, and it's very upset with me that there is no integer to do math with. Next up, we have sorting characters. So I've got lions and tigers and bears. It's a stream of strings. I've got a comparator. And then I'm trying to group my results by the length of the string and put the first character and the minimum value. And this does what I want. It tells me that for 5, I have bears, and for 6, I have lions, and tigers is the same length as one of the others. I don't want to count which one, but everything is fine. Okay, so now I have the same example with a very specific difference in it. Where'd the difference go? Ah, right. This time the comparator is no longer in a separate variable. It's just here. And this goes haywire. It begins by complaining there's no suitable method found, and then it goes on forever. You don't have to read this. It's really long and scary, and you would never find out what was wrong from this message anyway. The message begins with no suitable method found, But this is the actual stack trace. And it barely fits on the screen. And if you read the, oh, I'm sorry. If you read it's on my screen. If you read this, it's like, who knows what it does. But what it's complaining about is that I've left to inference what the comparator type was, and therefore it doesn't know and it doesn't work anymore. But that's not a useful message. And then there's a second message here about char app being invalid, which is actually more useful because it's like, oh, I didn't tell it the comparator was comparing characters, so it didn't know what it was doing. Okay, so the key here is that char and character are not the same, and the inferred type didn't know what to do with it. And then it propagated the error to the second call, which is how I managed to get that useful error out of the message. Because the first one is like, wow, that is a lot of text. Right, I'm supposed to figure out what I did wrong from that. Huh, fun. Yeah. Can we get IntelliJ to just do that for us? Like run the message through ChatGPT and tell us about the problem? Good. And then this one works again because I have told it in a little more detail what's going on. And I did that by saying that it is a string. So therefore it knows that I've got a string and I'm comparing strings, and it's allowed to do that. Our next topic is overloading. Overloading is fun. So I've got two overloaded methods here. I've got a number and an integer one, and I'm trying to delegate to them. So I get my integer, which is 42. I call check num, I call delegator, and I get integer number. The reason I get integer number, target.check is passing in an integer. Great, it calls integer. And target.delegator is taking in a number that happens to be an integer, but it remembers that it is a number over here. So when it calls the other guy, it's got a number and it passes the number forward. Okay. And then I have a similar example, but not completely. This time I've stored my integer in a number, and this time I get number out of it because num is a number. And the reason this is tricky for people is we're using objects and we're using instances, and you call target dot and it is a whatever, but that works for the object type. It doesn't work for the parameters. With the parameters, it's whatever you said the variable is. And what's fun with this is when you add var to it, because var makes everything clear. So now I've got var num equal integer value of. So I have to remember that num is an integer this time, and I get the original behavior because now my type is integer instead of number. So you can have three very similar examples and get different output based on what your stated type is, even though the actual object itself didn't change. And the reason for this is that the method is chosen at compile time and not runtime. So it makes it available based on what you said you were calling. So since var is using integer, it's as if we had typed integer, which was the same as the first example. Okay, equal. This one's a classic. I've got two integers. Their value is 8. I output this, and it tells me that they're the same. I've got two integers. Their value is 8,000. It tells me they're not the same because one of them is bigger than the value of 256 in the integer cache. So they are different objects, whereas in the former one, they were the same object. You should never do this. Then it doesn't matter. But the wrapper class does cache small values, and you should use equals and not have this problem because who needs unnecessary problems? This one's fun, especially in the face of cloud. So I've got an example here. I've got two URLs. They are the same. And if I print them out, I will get true because Google is a fairly stable service. And if I make two calls to it in a very short period of time, I'm going to get the same results back. What's fun is where this fails, though. If you have a cloud URL, and not any cloud URL randomly, but some specific cloud URLs that exhibit the problem where they change frequently, and you do this, you might get true, but you might get false. It depends on whether the DNS believes they're the same value. And if you're doing something where the value of your URL can change frequently because you're constantly spinning up and down your service, you can actually get false out of this, even though it's the same URL. Because when it checks the DNS a teeny bit later, it refers to something else. And the equals method on URL is not just going by the stated value you've given it, it's going by what it resolves to. The solution to this is you should be using URI and not just URL so that you get consistent behavior, or just not comparing equals values. But it's really surprising because it's like you would expect that it would be true. It's like you created it, it had the same string in it, and it's not necessarily the same. So use URI, you don't have unexpected behavior.
Performance challenge there, depending on how your DNS is going.
Yeah.
DNS is always the problem.
No, sometimes it's the network. And there's a nice article that explains this because it's like, really, it does that? I want a source. I don't believe you. So there's my source. It actually does do that. The next one I encountered personally. I do a lot of reporting on my team, reporting on data, reporting on metrics, reporting on various things. And one of the things I do at the end of the year is I produce a bunch of metrics that people have asked me for. It's always random things, so I'm always writing new code for it. It's like, oh, can you give me a report for whatever? It's like, yeah, sure, whatever. So I'm doing a lot of stuff around the end of the year, probably because I don't take off at the end of the year, so all those tasks fall their way to me, but that's fine. And I uncovered some interesting behavior, which I then reproduced as a test case that didn't belong to my employer, so I could share it out in the real world. And this is my case. So it's Christmas Eve. I updated the years for currency, but this problem occurs most years. So I've got Christmas Eve, no problem. I've created a local date. It's Christmas Eve. I've got my week fields, and I ask it to give me the week number. And I also ask it to give me the week of the year. And it gives me 52. All right, Christmas is within the last week of the year. I'm willing to believe that without looking it up. This seems perfectly reasonable to me. Cool. So I'm doing my reporting and everything's fine. And then we get up to the last week of the year, which is really fun. So I've created New Year's Eve, the 31st, and I've asked it for the same information. What is the week of the year and what is the week number? And I am told that the week of the week-based year is 1 and the week of the year is 53. Like, what? But it's this year. And this took me a really long time to figure out what was going on because, of course, this wasn't the code that I wrote. The code that I wrote assumed that the week of the year did what I expected it to and tabulated a bunch of data. And it didn't look right for the beginning and end of the year. And then I had to go figure out why, and this was why. So what's going on here so that you don't have to deal with this? Most weeks in the United States are 52 weeks plus 1 day. Great. 2025 started on a Wednesday. The week-based week starts the Sunday before. So Wednesday is in the middle of the week and does not give you what you want because week of year returns 1 through 54. So your week of the year could be before you started, could be after, and there are not 54 weeks in the year. But because it's counting partial weeks, you get up to 54 because there's the 52 that you would expect, and then there's the half a week before it, which is week 1, and the half a week after it, which is week 54. So, sure. So if you're doing any reporting that assumes there's 52 weeks in the year, you have to make sure that you use the right one or you don't get the right output. Well, that's all well and good, but all right, fine. I know that now. So everything should go better because now I know this, but it still doesn't go better. Because there's another variant of this problem that I should have seen coming after I solved the first problem. I did not. So we've got our same thing. It's Christmas Eve again, and I'm outputting the date, and I was sloppy, and I didn't worry about whether I was using lowercase or uppercase Y's because, quite honestly, they look almost the same, and they both print out the year, and they both print out 4 digits for the year, and this is good enough for me. And I'm testing, and they all work the same. It prints out the current year. Everything is good. So I go on, and now I'm doing it for Christmas Eve, and everything falls apart again because it's now the future. This is the same problem. It's our week-based year thing again, where there are 54 weeks in the year. So the year that I'm asking about on Christmas Eve is the middle of the week. So it's telling me that it's next year because next year starts in that week. But it's not next year. And it is most certainly not New Year's Eve of 2026 because that hasn't happened yet. I will grant you that 2025 New Year's Eve also hasn't happened yet. But, let's pretend that we're doing reporting for this year and it has. So you got to be really careful because these two are not the same. Lowercase y is the year. Uppercase y is the week of the year. And we recently learned there are 54 weeks in the year, not 52 weeks in the year. For any of you who have little kids, do not go home and say you learned there are 54 weeks in the year. Their teacher will be very mad at you. But for those of us who are computer programmers, people in this room, there are in fact 54 weeks of the year, and you have to specify that you do not want that in your result set, because the people I am reporting this data to are not programmers, and if I give them a report that tells them what happened on the 54th week of the year, they are going to send it back and tell me I did it wrong, and perhaps you are not our source of reporting data anymore because you looked at this and thought it was reasonable.
So then you can say I rape-around it so that I got out of having to do it, right?
Management kind of wants the report and not a whole story about the report. So fascinating problem, but okay then. Next up, we have closing resources. Try catch was added to the language, I think, in Java 7, and it's great because try with resources rather. It's great because you don't have to worry about closing all your resources, mostly. So I've got a prepared statement here. I've got try, and that means after the try with resources ends, it closes my resource. Everything is good. All right, so now I'm good. I'm going to be clever, and I'm going to do the exact same thing, and this does not work. This has a resource leak in it because there's a period of time where things can happen. So if this fails, I never get up to my try with resources, and it doesn't close my resource. So I have to be super careful there because it could call it and I don't get the safety that I think I'm getting. Similarly, I've got, okay, fine, I've done it inside the try with resources. All better. Great. I've got another example here with IO. I've created a file. I read from the file. Everything is good. No leak. But this code is really wordy, and we don't have to do this anymore because we could write this code in one line. I can do files, line path, count, and have it tell me the number of lines in the file. But alas, this has a resource leak because files.lines is the part that is the auto-closable, and it's not in a try with resources. Since the terminal operation does not close it, it's just counting things. Nobody ever takes care of closing the file. So you have to make sure if you're using any of these methods in IO that you take care of the try with resources. And the pattern here is you create a stream. Var is great here because nobody cares about the type, and have try with resources close it for you. Still shorter than the long form that we used to write by hand, but longer than the one-line version that you would think is just fine. We're nearing the end. I know everybody's tired. So we've got plus plus. We all know what I++ does. So let's look at a couple of examples of that. Here I've got teams plus 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 plus. You can't do that. It'd be kind of cool if you could, but you can't. The second plus plus doesn't go with anything. But you can if you have an operator in between. So this is legal Java. It updates 12. Don't write that. Terrible code. So you can't do plus plus twice, but you can do this because it is going to go through it for you and give you your value, and as a side effect, change teams. So it works. Don't do it. Makes everybody's head spin. And with that, it is time for questions before I give away the book. I know there were a lot of questions throughout, but does anyone have a question they've been sitting on? It's not 5. I changed the value of team twice. It says 7.
2.2.
Postfix plus plus would result in 5, but incremented after, then so you're adding pre-incremented 6.
It should be 5 plus 7.
Oh, I see what you're saying. Yes, I agree. I was looking at this set, the 7 that's not on the screen. I was looking at this 7, wondering why you were saying it should be 5, because it most certainly should not. I agree with the previous one. I'm going to change to a slide that's not the arrow while we're answering questions.
It's not a question, it's more of an observation. It seems like the more features they put in later versions of Java, it tends to lead itself to code that's not necessarily totally clear and might not run the way you want it to.
I don't know that that's a fair statement. I'm sitting here looking for things to show that are edge cases, so I found them. But it takes some looking, and we had some of those at the beginning, like the example on the last slide's been a thing forever. There are more of them in new versions of Java, though, because of the backward compatibility thing, right? So you get some things that don't work quite the way you would expect because we need to be backward compatible, but for the most part, the new features work the way you would expect them to.
It's just an observation that, I've looked at a lot of code over my career, and there are programmers that do clever things in the code.
Yes.
But it makes it less readable.
Oh, that is true. If you give those people more tools, they can definitely write obscure things.
But I think some of these new features tend into that camp.
Yeah, I agree. I had an argument with a contractor about how much code you should put in a Lambda. I'm kind of from the camp of you should not use squigglies to have statements and have one line. And if you have more than that, put it in a method reference. And he wrote a Lambda that was like this long. And I asked him to change it, and we had a whole argument about it. And he told me that I didn't know what I was talking about, and I told him I wrote a book. Because it's like that you don't know what you're talking about is not a valid argument, right? If he was having a design argument, I would have had a design argument back. But it's like, if you're going to give me a stupid reason, it's like, no, we're not doing this. It's like the code is hard to read. It's hard to maintain. I'm asking you to change it. You're not telling me that it's clear the way it is. You're just telling me I don't know. So it's like, I'm not participating in that conversation. Yes.
I think the VAR was introduced in Java 21, right?
It was before that. It's definitely before that.
But can you use it in method parameter?
No. The formal name of var is local variable type inference. So it has to be a local variable. It can't be an instance variable or static or method variable. And the reason for that is var is getting its type by what is on the right-hand side of the expression. So in a method, there is no right-hand side of the expression, so there's no place for var to get its type from.
You can use it in a Lambda though.
Yes. And you can also use it in a for loop. So it's kind of like, though technically those are local variables, although we don't think of them as such, but it has to be inside of the method, and it has to be a place where it can infer what it is. With lambdas, you can use it almost always. It is possible to create a lambda where it doesn't know the type, and then you're back to the problem. But also with a lambda, it's usually you don't care about the type, and the reason you're adding var is because one of them required an annotation or a type, and now you're stuck defining the others, so it's like, fine, var, go away. Because if you didn't need any, you wouldn't put a type at all, and you wouldn't have this problem.
If you use it in Lambda and use the Lambda as a reference, like, does the type of the var changes if you pass it in different like strings or in different, if you pass, say you have a list of objects or a list of strings or a list of integers, and then you pass it, then
I want to say yes, but I'm not 100% sure. Does anyone feel 100% sure answering that? I see a hand. Are you comfortable?
No.
No? Okay. So we're going with yes, probably, but I would have to try it to be sure. Yeah. But that sort of falls into the clever, let's not do that thing. Other questions? Okay. It appears we are out of questions, so we're now going to do the raffle for this book. Oh, you're not out of questions. I lied.
Yeah. I learned a lot. This is great. But I was kind of expecting you to go into something like virtual threads.
I didn't find any gotchas in virtual threads. They work the way you would expect them to.
I haven't worked with them much yet, but I just was wondering, supposedly they bring performance improvement.
Oh, they do. They're awesome.
And also, as you said, Z garbage collection. Also, same thing, performance improvements.
Yeah.
I only got to touch base with them briefly in my last job before.
Any other questions or comments?
I think there was a previous judge talk where he talked about virtual threads, and he kind of said that they're kind of, you treat them the same as normal threads.
Yeah. So, okay.
Okay. Question or stretching? Okay. All right. So now we're going to do the book. The way